and welcome to Chapter 3, Sequences and Series. You should already have some basic knowledge on this chapter since you have been introduced to sequences previously in your secondary school. So basically in this Chapter 3, we will have two subtopics. 3.1 will focus on arithmetic and geometric sequences, while 3.2 will be on binomial expansion. So let us go to 3.1, arithmetic sequences. Note that I will use AS to represent arithmetic sequences throughout the video. So in an arithmetic sequence, the difference between one term and the next is a constant. In our example here, we have an ascending order of AS with 4, 7, 10, 13, and so on. As you can see in this sequence, the common difference between all the terms is 3. So generally, we can write an AS as A plus D, A plus 2D, and so on, with A as our first term and D as a common difference. We can get D by using Tn plus 1 minus Tn, and note that n is always a positive integer. The nth term of an AS is given by Tn equals to A plus n minus 1D. And we have two formulas for the partial sums of AS as follows. We will go to the first example, example 3, to find the first 6 terms and the 300th term of the AS given. So this AS given is obviously in descending order, with A 13 and D minus 6. So to find the first 6 terms, we first need to find Tn of our AS. To do so, we have to use the formula earlier. Tn equals to A plus n minus 1D. And substituting our A and D, we will get Tn equals to 19 minus 6n. So from the sequence, we already have our T1, T2, and T3. And to find T4, we need to substitute n with 4 into our Tn to get negative 5. And do the same for T5 and T6. And lastly, we have to list out all the 6 terms as the question asked. So to find the 300th term, this is actually T300. To do so, we have to substitute our n with 300, and calculating it, we will get negative 1781 as our T300. And we're done. Now look at example 5. How many terms of the AS 579 must be added to get 572? So this is an ascending order of AS, with 5 as the first term A and D is 2. The 572 here is the sum of our first n term, where we do not know our n. So that is what we're going to find in this example. So first we will write down as n equals to 572. So by using the formula for the partial sums of an AS, we substitute our A and D into the formula and equate it to 572. We simplify the left-hand side to get a quadratic equation, and solving the quadratic equation, we will have n equals to 22 or n equals to minus 26. So as stated previously, n is always a positive integer, so we use n equals to 22. And we're done. Moving on to the next example, example 6. The sum of the first n terms of an A progression is given by Sn equals to 3n squared plus n. Find the first term and the common difference, and hence the 21st term. So 21st term here is T21. So as we can see here in example 6, there is no arithmetic series given to us. So we do not know our A and D, but we are given our Sn. So we will just use our Sn throughout our method to solve the question. So to find A, the first term, we can get our S1 because S1 is the sum of the first term. So to get A again, we substitute n with 1 into our Sn to get 4. So now we have 4 as our first term in our sequence. We next have to find T2 in order to find the common difference. To do so, we have to use a formula Tn equals to Sn minus Sn minus 1. So we have S1. Now to get T2 here, we obviously need S2 and S1. So we have to find S2. To find S2, we substitute our n with 2 in our Sn equation. And to get 14, then T2 is equals to 14 minus 4, which is 10. So now, in our sequence, we have the second term as 10. So the common difference will be 10 minus 4, which is 6. Next, to find the 21st term, T21, we have to use our previous Tn formula, and then substituting our A, D, and N into our Tn to get 1, 2, 4. And we're done. Next, example 7. We have an insurance representative which made 3,000 ringgit Malaysia her first year and 60,000 her 7th year. Assume that her annual salary figures form an AS and predict what will she get in her 10th year. So here, again, we are not given a series, but we are given 30,000 in her first year. So we can say that this is the first term, A. And then 60,000, the 7th year, so this is our T7. So we have T7 equals to 60,000. So by using our Tn again, we can get an equation of 30,000 plus 60 equals to 60,000. And rearrange this equation, we can get our D, which is 5,000. The question asks to predict what will she make in her 10th year. This means we have to find T10. And to do so, we have to substitute our n equals to 10 into our Tn formula with our A and D found previously to get 75,000. So in her 10th year, she earned 75,000 ringgit Malaysia. And we're done.